Okay, well, I hope everybody had a good weekend. We're in the second week of our grading period. A few big items to keep in mind. This week, tomorrow, your homework is due, the right triangle trigonometry. We already turned in angles and their measures on Friday. So tomorrow, I did change it. We're going to have ourselves a short exit ticket. I'm thinking about giving you 6 minutes. It's going to be on angles and their measures. So should not be too bad. Conversions, finding the quadrant that a terminal side is going to fall into. So you'll want to be looking at that material. On Wednesday, we're going to have a right triangle trig CFA. So remember, the CFA means we're going to be doing it on the Chromebook. I won't have any paper copies, so you'll be able to use like a scratch sheet of paper if you're wanting to. You'll input your answers, and we'll go from there. The big one is coming up on Monday, the 14th. A week from today, you're going to have your first exam. So look for it to have angles and their measures, right triangle trig, even some of this material right here coming from arc length, circular motion. Probably we're going to have a problem from linear and angular velocity, which we're going to spend the majority of our time on this week. Hopefully by the end of the week, definitely by Friday, I'll be able to introduce the unit circle to you, because that's going to be paramount for what we do here on. The only other thing I got up on the board here, so I wouldn't forget, the retakes. Okay, so one change I'm going to go ahead and make, you definitely have to have the homework assignment done in order to get credit for the retake, right? But because of what happened a lot over the first 6 weeks, you have to have the assignment done before or by the time you retake. Okay, so if you retake, I go in and you haven't turned in the homework assignment, I'm going to file away the retake. Basically, you forfeit it. Okay, it has to be done before or on the day you take that retake. You cannot turn it in after. I want to get that taken care of. Okay, questions on that? All right, so I'm not going to come looking for folks. Please get that taken care of. The only other thing, the digital copy of the book, if anybody wants that, that's still available. Let me know. I'll sign that to you. And let's talk about arc length and area of a sector. In geometry, we found if given a central angle and the length of the radius, we could set up a proportion to find the length of an arc in a circle. The arc length is a fraction of the total circumference, and the central angle is a fraction of a full revolution. So one way to do this, and there are several ways to find arc length, a proportion is one of them. One of the first ways I was taught was to take the measure of the central angle over 360 times 2 pi r. So again, we're just taking a portion of the circumference. Now remember, the circumference is the complete distance around the circle itself. So when we say we're taking a portion, we only want a part of that. That's what we're referring to when we're finding the arc length. Okay. Now, our formula is going to change slightly again. It's a very, very simple formula. S is going to be our arc length. R is the radius. Theta is the measure of that central angle. So S equals the radius times theta. There's only one catch. Theta has to be in radians for this formula to work. And it's really easy to forget. If you input degrees, you're going to get an answer, but it's not going to be the correct answer. Okay, and then this little portion right here in the middle, this is a derivation of it, so I'm not going to worry about going through that. I'll let you look at it. But let's get started. Example 1. Given a central angle of 60 degrees and a radius of 8 centimeters, find the length of the intercepted arc. Okay, so again, I'm a very visual person. I like to go ahead and typically draw a picture with it. So we have a radius, which is 8 centimeters. Okay, we've got a central angle of 60 degrees. So let's say this is 60 degrees right here. And what we're trying to find is, based on that 60 degrees and the length of the radius, well, what's the length of that arc created by the two? Okay, just a portion of the circumference, as I mentioned a moment ago. All right, well, we have a formula. The arc length is equal to the radius times theta. The only catch, theta's got to be what? It's got to be in radians. Okay, so we're given 60 degrees. How do we convert that to radians? What was our little expression? We got to multiply by pi over 180 degrees. Remember, those degrees are going to cancel. What's left is radians. In fact, what would 6 1/80ths be? Yeah, 1/3. So we got pi over 3. Okay, and it's just a matter of substituting into the formula. The arc length we're looking for is going to be the 8 centimeters times theta in radians, pi over 3. Now that is 8 pi over 3. Okay, so we're going to go ahead and approximate that. Come on over here to the calculator. There you go. So I'm going to hit Control Divide. Now, if you're looking for pi, there are several ways to find it on the calculator. I like to use the bottom left corner. There's a button that actually has pi labeled on it, and it has a lot of useful items here, but we just need pi over 3. All right, and this is exactly what Connor told me. So I'd say 8.38 centimeters. And there you go. There's your arc length. Questions? Okay. All right, well, let's take a look at the next one. So it's going to switch it up a little bit for us. It says if a 100-degree arc has a circle has a length of 9 inches. Okay, to the nearest inch, what's the radius? So we don't know what the radius is this time. We have a central angle of 100 degrees, and I'm provided the arc length is 9 inches. Okay, so we're still using the same formula. We just kind of have to work backwards in order to find that radius. All right, so while you're trying that, let me go ahead and pass back your quizzes. And if you haven't noticed, your class average was an 85. You guys did very well, but you did not take the top slot this time. 8th period got it with 92.1. Okay, so you still did a really good job. Now, if you finish up number 2, and I haven't finished passing the papers back, go ahead and try number 3. Okay, arc length is equal to the radius times theta. All right, so I also have some papers to pass back in addition to the quiz. Presumption. Okay. There we go. Sandra. Jake. Laura. Philip. And if anybody had any questions, we can talk about them at the end. Josh, Fernanda. Okay, Tori. Okay, Michael. Adrian. Kate. Xavier. Elon. Caleb. Lane. Would you pass that, please? Jordan D. Jordan V. Connor. Okay, Noe. Go. Natalia. Andrew. Will's not here. Connor. Kate. Eli. Presumption. Jordan V. And if you have finished up both 2 and 3, you can check with your villain buddy, see if you guys are getting the same responses. Okay, Fernanda. Okay, select. Caution. Philip. Okay. There you go, Jordan. Ooh, got it. Michael. Ooh, sorry about that. Caution. Kate. And that's it. Okay. Okay, now while I'm thinking about the quizzes, this morning was the last time you could retake the difference quotient exit ticket. Tomorrow morning is the deadline for the compositions quiz, and then this inverse quiz I just passed back, you have until Friday morning if you want to retake it. Just again, you got to make sure that you have that assignment turned in before or by the time you take it. Okay. So let's go ahead. Let me catch up with you folks real fast. S is equal to r theta. Okay. So let's start with theta here. We have 100 degrees. How do I change that to a radian again? Pi over 180. Okay, those are going to cancel. So I got theta is equal to 5 pi over 9. Is that what everybody was getting? Okay. Then I go ahead and plug in. Now this time we know the arc length, so 9 is equal to the length of the radius times theta in radians. Now I can go ahead and divide through by that fraction, but it might be more efficient to do what? Multiply by what? You could just go ahead and multiply by 9. Perfect. So 81 is equal to r times 5 pi. There we go. And then we divide through. So I got the radius to be 81 over 5 pi. Okay. There we go. Now we wanted to go ahead and do this to the nearest inch. So let's see what we should be getting. 81 over 5 pi. All right, so what should I be getting when I push enter? Yeah, so I'm getting like 5.16, so let's say 5 inches, because it does say to the nearest inch. How many people had that one right? Okay, good. Good, good, good. All right. Does anybody want to tell me what they got for number 3? What was my answer in degrees to the nearest degree? Or does anybody have an answer, but they're just not 100% sure? Okay, Connor, what'd you get? 92. 92. That is exactly right. There you go. Anybody else get 92? Well, see, now there's a lot of hands going up. You know, be confident. Confident. Okay. So let's talk about how we got that. Find the angle in radians, then convert to the nearest degree. Okay, so for this one, we have everything we need except for theta. We have the radius, we got the arc length. So S is equal to the radius times theta. So the arc length is 8 is equal to the radius 5 times theta. So we can see that theta equals 8/5. Now, what kind of angle measure is that? Is it degrees or radians? It is in radians. The only way this formula is going to work is if theta is in radians. So this is one of our first examples where we see a radian measure that doesn't have pi. And it's very, very possible for that to happen. In fact, it's going to happen a lot. Okay, so now we know theta. We just need to know it in degrees. So 8/5 times, how do I convert it to degrees? 180 over pi. And there we go. And you do end up getting 92 when you round it to the nearest degree. Does anybody want me to go ahead and plug that in? Anybody like to see that? Jake, I can't tell. You're shaking your head yes or no? He is shaking his head yes. Okay. So let's see here. Parentheses, control divide. So I got 8/5. Let's get out of there. And then I'm going to multiply that by 180 over pi. Whoa. Okay. Well, I got the pi. Let me escape out of there. There we go. Okay. And the 8/5 radians times the conversion, 91.67, which is where we got our 92 degrees. Okay. Is anybody having a hard time? Anybody confused? Okay. Now, the majority of what we're going to spend our time on in this lesson is linear and angular velocity. So instead of going straight to it and then coming back to these problems, let's skip to the end of the packet. We're going to go ahead and talk about area of a sector, do a couple of arc length application problems, and then maybe today, but definitely tomorrow, start talking about linear and angular velocity. I'd rather not chop it up. Okay. All right, so if you go to near the end of your packet, oh, and while I am going to that part myself, tomorrow we are finally to that time where I'm not going to be having copies for some of the things we're going to be talking about in class. We are going to do examples that are in the packet, but I've also got some, I think, better examples for linear and angular velocity that I'm going to be posting to the website sometime later today. All right, it's going to look like this. First one's going to be talking about a vinyl record, and the next one's going to go through a bicycle. I think I've got like 5 or 6 problems to take a look at. The reason I'm showing these to you now is because when we start going over these tomorrow, I'm going to give you a little time in class to copy, but you're not going to have the time you need to copy it down word for word. Okay, so we need to know how to go ahead and summarize, or if you're just not a very strong note taker, maybe go ahead and print this off at home, have them pre-copied. I've got a person who's going to be using their iPad. They're going to go ahead and pull it up as a PDF and then just write on it directly. So whatever you think is going to be best for you. Okay, so you will have a little time to copy, but unfortunately you won't have enough time to copy. You'll have to go to the website. Everybody okay with that? Okay, so just kind of giving you a heads up about that. Let's see here. Got a few more problems. There we go. Area of a sector. Okay, so like we talked about in the beginning, there are several different ways to go ahead and find the area of a sector. Proportion is a great method. One of the first ways I was always taught was the measure of the central angle over 360 times pi r squared. See, I'm only taking a portion of the circle's area. Okay, and that's all we're talking about. Kind of envision a pizza. One slice is what we're referring to as a sector. Okay, so we're only finding the area of that one slice. Now here's our formula. 1/2 the radius squared times theta. Again, theta's got to be what? In radians. They are very simple formulas. You just got to make sure that theta is in radians. Okay, well, let's try one of these. Example 7. Find the area of the sector of a circle of radius 2 feet. Okay, so I got a circle with a radius of 2 feet. Okay, formed by an angle of 50 degrees. Okay, so let's say 50 degrees is right here. Now, what I'm talking about, I don't want the arc length. I want the area of that sector. Okay, so in this case, our final answer should be in squared feet. All right. Now, you could go ahead and do like we did in the previous examples where we found theta over to the side. We went ahead and converted it. But I've noticed throughout the years that students just go ahead and take care of it all at the same time. Let me show you what I'm referring to. The area is equal to 1/2. Okay. Well, what's the radius squared? 4. So I'm just going to go ahead and plug in the 4 times. Now, my central angle is 50 degrees. Okay. But I know that that has to be radians, so I'm just going to tack on to the end of this formula the pi over 180 degrees. So see, I can just take care of everything at one time. I don't have to worry about finding theta separately and then substituting in. If this is something you like, use it. If not, fine. Okay. Now, I would even simplify it a little further. What's 1/2 of 4? Okay, 2 times 50, 100. So I can just go ahead and type in 100 pi over the 180. And I can even simplify the 100 1/80ths if I wanted to. Okay. Or I could type in the full expression, whatever you like. Now, regardless of what you do, how many square feet am I looking at? Okay. So I'd say 1.75 square feet. Perfect. It did say to round to 2 decimal places. Okay. So we rounded that to the nearest hundreds. Is everybody okay with that? Anybody have any questions? Everybody's okay where I got the 100? Okay. Hey. Oh yeah, that doesn't matter at all. If I go ahead and type it in exactly as I have it right here, like if I were to go ahead and say 0.5 times 4 times, now if you go ahead and actually multiply 50 or keep the 50 separate, again, makes no difference. Okay. Still going to give me the same result. Yeah, so completely up to you. Okay. All right, good, good, good. Now, the area of the sector, again, that's very straightforward like the arc length, but we're going to go ahead and start focusing a little more on arc length. That's what number 8 is. So this is not an area of a sector problem. It says, okay, Memphis, Tennessee is located 35 degrees 9 minutes north latitude, and New Orleans, Louisiana, you like the way I said that? New Orleans. It's a Monday. Okay. Is at 29 degrees 57 minutes north latitude. Assuming that the radius of the Earth is 3,960 miles and the cities lie along the same longitude, find the distance between the two cities. Okay, so the Earth isn't a perfect sphere, okay, but just kind of imagine it is for our purposes here. If you're going to find the distance between two distances on the surface of the Earth, you realize it's not a straight line. It would actually be a arc. Is everybody okay with that? Okay, so that's why we're going to go back to this formula here. The arc length, our distance between the two cities on the surface of the Earth, is going to equal the radius times theta. So again, very simple formula. You just need to have two parts. The only thing we got to make sure of is theta. So let's see what we got here. This is a cross section of the Earth. So 3,960 miles. Okay, now we know that Memphis is going to be located at 35 degrees 9 minutes, okay, north latitude. And then we have New Orleans located at 29 degrees 57 minutes in north latitude. Okay, so what I'm looking for is the distance between them on the surface of the Earth. I want that arc length. So I need this measure, the central angle theta, created between them. Any idea on how I can do that? Hey, Connor. That's exactly right. Just subtract the 2, and that should give me this measure I'm looking for. So I'm going to go ahead and take 35 degrees, 9 minutes, minus 29 degrees, 57 minutes. Now, we're going to go ahead and get the opportunity to work with these by hand in just a minute, but I did show you, I think it was last week, or pretty recently, how to put this in the calculator. So I'm going to come on over here. Where do I find degrees, minutes, seconds in the calculator? Okay, so if you look right here, this button between 9 and your catalog, okay, you want the second row, second column. This one's already highlighted. So remember, it was a fill in the blank for DMS. So we have, what was it, 35 degrees, 9 minutes? And I don't believe you have to put a 0 in here if there are no seconds, but I'm going to go ahead and do that anyway. I believe it'll still work. Minus, and then let's do the same thing. Okay, make sure it's in the correct position. Okay, and then what was the other one, 29:57? Okay, 29 degrees, 57 minutes, 0 seconds. Okay. Now, we're not going to know what the exact degree measure is individually, and that's okay. We're just going to go ahead and get the difference here. Now, mine gives me 26/5, so I'm going to hit Control Divide, so it gives me 5.2 degrees. Okay. All right. Everybody okay? Now it's just a matter of plugging it into your formula. The arc length, the distance between the two cities, would be the radius, 3,960 miles, times, we have 5.2 degrees, but I can't help but feel that I'm missing something. Remember, it's got to be in radians. So I'm just going to tack on at the end of this formula that little conversion. So I'm going to multiply by pi over 180. So see, those cancel. Is everybody okay with that? Is anybody confused? Okay, so let's type in and see what we got here. 3,960 times 5.2 times Control Divide. We're going to put pi over 180. Okay. So how many miles apart are Memphis and New Orleans? According to this, anyway. Okay, I'm getting 359.4. Is everybody okay? 359.4. Okay, questions. Anybody not sure where I got something from? Okay. Well, we got a couple more, and then we'll see what will happen after that. Now, in order to do these, you'll notice up here I put the conversion from that chart on a previous assignment. Remember that 1 degree is equal to 60 minutes, but 1 degree is also equal to 3,600 seconds. Okay. So some earthly discoveries. Compute the length in feet of an angle measure of 1 minute on the Earth, given that the radius of the Earth is 3,960 miles. Okay, so here's the thing. The Earth is rotating. Now, even though we may be standing still right now, how far of an arc distance would we travel in 1 minute? Okay, so imagine you have a ball in your hand with a point on it. If you were to rotate it, well, how far would that spot have rotated? What kind of arc length distance have I created? Is everybody okay with what we're trying to figure out here? Okay. All right. Well, the good news is, what's my formula? Remember, how do I find that distance, the arc length? Okay, the radius times theta. Do we already know the radius? 3,960. That's already half of what I need. But we need to be able to take theta and get the radian measure. All we know is that we're rotating 1 minute. Can anybody tell me how many degrees that is? 1/60th of a degree. 1 minute is equivalent to 1/60th of a degree. The dog agrees. See? Okay. You think this problem is rough? See, he said no. It sounds like it's in the courtyard, doesn't it? Well, there's a bunch of students down there. Oh, what's that service animal's name? Rex. Yes, so Rex is down there. Okay. That dog's actually pretty cool. Okay, now let's go ahead and talk for a minute. Is there anybody who wants me to elaborate on where I got the 1/60th of a degree? So everybody feels confident about that. Anybody should be able to do it by now. Okay, all right. Remember, if nobody says anything, I got to assume what? I got to assume you're okay, and we'll move forward. What I did, kind of think about it as a proportion. If we know that 1 degree is going to give me 60 minutes, okay? Well, let's go ahead and set up another ratio, degrees over minutes, but finding what I need. I want to know how many degrees are in 1 minute. Okay, but how do you solve a proportion? You cross multiply. Okay, so 60 times x, I've got 60x. Remember, x is in degrees, equals 1 times 1, 1. So x equals 1/60th. That's where we got the 1/60th of a degree. Okay. In fact, was there anybody in here? There was only, I believe, 2 people out of all my pre-cal students who asked me how we convert by hand on that previous lesson. Was anybody in here one of the ones who did that? Okay, all right. No, did I show you how to do it with the 1/60th? Yeah, I think so. Okay. But there you go. That's where we got the 1/60th from. But now that's in degrees. Am I missing anything else? Still got to make sure that's radians. So I got to change that to pi over 180 degrees so that those degrees cancel. Now this right here, this is the theta measure I need in radians to make the formula work. So all I need to do now to find that arc length, how far a distance we're basically going to rotate within 1 minute, is multiply the 3,960 times the 1/60th times the pi over 180. And then there's one additional step we're going to have to do. So we'll get there in a minute. Some people are probably already realizing what I'm talking about. So let me get rid of this. 3,960, parentheses, control divide, 1 over 60. Okay. Times, control divide, then we got pi over 180. Okay. So how many miles will we have traveled in that arc within 1 minute? I'm getting about 1.15 miles. Okay. But now be careful. What's the question say? It says feet. So we have to do a little bit of dimensional analysis here. So I got this to be about 1.15 miles. Now, that's 1.15 miles per what? 1 minute. Now, we want to know how many feet per minute we're doing. So we need to go ahead and cancel out the miles. So I'm going to go ahead and create another ratio here. And we're going to be doing a lot of this when it comes to linear and angular velocity, because you could be given inches and you want your final answer to be in millimeters per some unit of time. Okay. So where am I going to put miles? Would they have to be above or below? Below, because I want those to cancel. We're going to convert that to feet. Now in 1 mile, there's how many feet? Five of what? Not 500, 5,280 feet. See, now the miles are going to cancel. Now we're going to have feet per minute. Okay. This is what we call dimensional analysis. Some teachers have referred to it as train tracks. Does that sound familiar? That's weird. Normally, in years past, a lot of people have heard more about train tracks, but nobody's responded to that this year. Huh. So all I got to do is take this and just multiply by 5,280. Okay, so I'd say we've created an arc about 6,082.1 feet long. 6,082.1 feet long. Okay. Any questions? Is anybody having a hard time? You guys ready for one on your own? Okay. Let's try the next one. Now 9b says, what's the length of an angle of 1 second on the Earth? Now there's two ways you could do this. If there's something that you notice, you can get the answer in one step. Otherwise, set it up the same way we did this problem here. You'll have to convert theta from seconds into degrees, and then you'll have to convert that to radians. Okay. Now, just like we did on the previous one, let's go ahead and make sure that our final answer, it doesn't say it, but let's go ahead and do it in feet. Let's make sure our final answer is in feet. How are we doing on time? 10:37. We're doing good. Okay, while you guys are finishing that up, we do have a drill this week. Does anybody know what it is and what day? We have a fire drill on Friday during 6th period. Friday during 6th period. Okay, so wherever your 6th period class is, you're either going to be going to the east or the west parking lots. You know, let your teacher count the roll. Do you got it, man? That's exactly the little shortcut I was talking about. Because you've already found it in minutes. So all I got to do is divide by 60. That's right. You know. Now, I'll go ahead and work through the problem when the time comes, and then I'll go ahead and show you the shortcut, which a few people like Presumpsa has already figured out. Okay. And remember, if you're not sure, check your answer with your villain partner, villain buddy, see if they're getting the same thing. If you're getting the same response, fantastic. If not, we'll talk about how we did that. Okay. Is everybody about ready? Can anybody tell me what should we be getting as a final answer? Okay, I got 101.4 feet. Fantastic. Let's talk about how we got it. So the arc length is the radius times theta. Now theta this time is in seconds. So what's 1 second in degrees? 1/3600th of a degree. Okay, that's exactly right. Does anybody want me to set up the proportion to show you how we'll get that? Very similar to what we did a moment ago when we converted the minutes to degrees. Okay, now we got to multiply this by pi over 180. So those degrees cancel. Now this right here, this product represents the radian measure I need for the formula. All I would need to do is multiply this by what? The radius of the Earth, 3,960. Okay, so 3,960 times control divide, we'll have 1 over 3,600. Let's get out of there. Parentheses, control divide, we got pi over 180. Let's get out of there. Okay. Now, wait a minute. I thought you said it was 101.4. What's this in? This is in miles. This is how many miles you're going to travel in 1 second. So we got to multiply it by the 5,280, which is where we get our 101.4 feet arc that was created. How many people got that right? Nice. Okay, questions? Anybody having a hard time? Okay. All right, well, here's where I'm going to go ahead and kind of stop for just a minute. Is there anybody who had questions on the quiz? Let me go ahead and erase this while you guys are looking at that. And if there are questions on the quiz, we'll go ahead and talk about it. And if there are not questions on the quiz, then we will go ahead and move on with linear velocity. Any questions over the quiz?
Can you just go over number 1?
Just go over number 1? Okay. I believe the function was f of x equals, was it 3 minus 2x squared? 3 minus 2x squared. Okay. Let me go ahead and sketch this very quickly. Now here's the thing. We don't need the domain and range of this function. That's one of the things I didn't ask for, but it is useful to have. What would 3 minus 2x squared look like? He's definitely a parabola, but what's been done to it? Okay, it's opening down because of the negative. What's the 3 going to do? It was shifted up vertically 3 units. What about that 2? Is it going to make it skinnier or fatter? Okay, that's a vertical stretch. So probably we're looking at something like this. But I told you something in the instructions. What was it? I want you to restrict this from 0 to infinity because right now he's not 1-to-1. He wouldn't pass the horizontal line test, so his inverse would not be a function. But we want his inverse to be a function. Now, because you could have chosen to eliminate the right or the left side, I just went ahead and put that in the instruction so that everybody was on the same page. All right. What's his range? From negative infinity to what? There you go. Negative infinity to 3 included. Now, because we're guaranteeing that this guy here is going to be an inverse function, not an inverse relation, do I already know the domain and range of the inverse? Yeah. Because I was provided the domain of the original, that's the range of the new one. Okay. What would the domain of the inverse be? Negative infinity to 3. There we go. So if I were to sketch this, maybe 1, 2, 3, this is not going to be perfect, but it's going to look something like that. Okay, we started with half a parabola, so we finished with half a parabola. Did you want me to go ahead and find the inverse function too? I think a lot of people did really well on that. If anything, they may have gotten a point or 2 off because of signs. That was the biggest problem I saw on the inverses. But as far as finding them, people did well. Did anybody want me to finish this problem? Okay. Anything else? Hey.
You work the second one.
Work the second one. Okay. Now, I know I gave you 2 functions. F of x, can I borrow somebody's quiz? F of x equals 1/2 x plus 3 halves. 1/2 x plus 3 halves, and I gave you g of x is equal to 4 minus 3 halves. Okay. Now, I gave you 2 blanks that I want you to go ahead and fill in. The first one here was f of f inverse of x equals f inverse of f of x equals blank. And then the other one, is it, are they inverses of each other, yes or no? Well, this one right here, this was not only your hint to tell you what to do in order to answer the question, but I also did want you to complete the statement. Okay, now these aside, if you have two functions that are inverses of one another and you compose them, what should you get? You should get x. You should be able to plug one directly into the other and get x. Remember, that was the line of symmetry for graphing these. And now the one below it was simply yes or no. Are these inverses of each other? So why don't I just go ahead and take one? Like, let's take 4 minus 3 halves x, and let's plug it into the other one. So 1/2 times the 4 minus 3 halves x plus 3 halves. So half of 4, 2 minus 3/4 x plus 3 halves. So this one right here would be 4 halves. Because remember, I need a common denominator, right? 4 halves is 2. So this would be a negative 3/4 plus what? Oh, forgot the x. Plus 7 halves. Well, did I get x? I did not. Do I even need to do the composition in the other direction? Nope, it has to work both ways. Since I did not get x, no, the f and g provided they are not inverses of each other. Okay. Does that make sense? Okay. All right. When is the retake? By what day? Friday morning. Friday morning by 8:05. Okay, remember, when you take the retake, if that applies to anybody, either you've already have to have turned the inverse assignment in or turn it in by the time you retake. Okay, got to take care of that. All right, so I'll tell you what, it's 10:47. I think we'll go ahead and stop there instead of moving on into linear velocity. We'll start there tomorrow after the focus activity, the homework, and the exit ticket. All right, if you will get your calculators up to the front, please.